Yo, my people. Sorry couldn't be here with you. We are still off on paternity leave. We'll be back soon. I can't tell if you like not having me around because it's easier or it's harder, or I don't know. So it'll be interesting to see how you guys do. I'm sure you're doing just fine. You're smart cookies. We are checking out 6.4 Binomial Expansion today, and you can put that at the top of your notes. And we're going to try this warm up. Before you jump in, I wanted to note that this is multiplication. This is all multiplication. It's like a times b, right? A times b times something else, c times d. It's a whole bunch of multiplication. Today, where we're going is binomial expansion. It really should be binomial multiplication. It's taking things like x plus 3 times x plus 2, right, and multiplying them. We'll talk about how to do that, but I just wanted you to see right now that we've seen this before, and that's multiplication. Where we're going is multiplying things with addition inside, and it's a different beast. You just have to be careful about separating which one's which, okay? So this warm-up is just multiplying with scientific notation like we've done before. So pause me and give that a shot. Go. Okay, I'm just kidding, I'm not frozen. So here are the solutions. If you got them, move ahead. If you didn't, let's try them out together. This is nice. Scientific notation is nice because it's just a whole bunch of things multiplied together. It's a times b times c times d, right? And so you can switch those. You can flip-flop them, just like 2 times 3 times 4 is the same as 4 times 2 times 3. Any order you multiply them in is fine. It's the transitive property, commutative property of multiplication, one of those two. So we can multiply the 2.1 times the 9.3, and it gives you 19 something. Oh, 19.53. And then, so we multiply these pieces. And then you can multiply these pieces, and when you multiply those, you just add their exponents. Now that's great, but it's not scientific notation. What we really want to do is move this 1 backwards. So this becomes 1.953 times 10 to the 10th. Great. You can do the same sort of thing here. This really is when you divide these two. You go 2.5 divided by 6.2, you get 0.403. And then this is times 10 to the, and you subtract these exponents. So 10 to the negative 5 minus negative 6, right? And that's all well and good. That turns into 0.432 times 10 to the, well, this is negative 5 minus a negative ends up being plus, and so you'd add them up and you get 10 to the 1. 10 to the first, 10, right? That's great, but this isn't in scientific notation, just like this one wasn't. If you're not sure which way to move this, you have to think about this piece. If you turn just this piece into scientific notation, I know that I'd move the decimal 1 this way, and this would turn into 4.032. This should have an extra O in here, right? Times 10 to the negative 1, right? And then we still have this chunk sitting off the back, times 10 to the first. And then you recombine these, and 10 to the negative 1 times 10 to the first is 10 to the 0. And so you end up with 4.032. times 10 to the 10 to the 0, which is really, you don't actually have to write 10 to the 0, and anything to the 0 is 1. So this is like 4.032 to the first. Yeah, or times 1, sorry, not to the first. So there you go. There's that guy. Last you were here, we were looking at factoring expressions, and we're going to go back to expanding. So at the end of the day, I want you to be able to expand binomial expressions by multiplying them. Use the FOIL method. Oh, it's a FOIL mnemonic device. Mnemonic device. Neat. We'll talk about what that is. Cool. Binomial expansion is the same sort of thing we've been doing before, except instead of having a monomial distributing into a binomial, right? This is monomial because it has one thing, and this is a binomial because it has two monomials separated with plus or minus. Binomial. We're distributing a monomial into a binomial. That's what we've been working with before. We're going to make this slightly more complicated but more useful. So this was easy enough, right? 7 times 2x gave you 14x, and 7 times 8 gave us 56, right? Algebraically, you can do it this way. You can say, I have 7 of these packets. So here's 1, 2, 3, 4, 5, 6, 7. Oh, did I freeze? Wow, that's cool. I've never frozen before. I feel like I'm miming this. I guess we're going to press on. Sorry, I'm frozen. We got 1, 2, 3, 4, 5, 6, 7 of these. If you rearrange and put all the 2 x's together, 3, 4, 5, 6, 7, you have 7 of those. If you put all the 8's together, you have 8 of those, right? There's 8 of those. There's 8 of those. And you can just count them up: 2 x's, 4 x's, 6 x's, da 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 da. You get 14 and 56 from the 8's. Same sort of thing. Here's a way to visualize it, though, right? So a generic way to visualize it is this. A geometric way to visualize it is this. This is 7 times some length, 2x, plus another length, 8, right? It's sort of like looking at the area of 2 different gardens, right? And this area would be 7 times 2x, and this area would be 7 times 8, and we just said 7 times this plus 7 times that, right? And we got an expression for it, for the area. Fine. We're going to do the same thing with a binomial, which has not. Was a monomial. We're going to try to represent this in the same way, but with a binomial and a binomial. So instead of having 7 times 2x plus 8, 7 times 2x plus 8, having 7 plus x times 2x plus 8, we're going to add another layer in here. And so you can sort of visually represent it like this, right? It's just like having a bigger, more complicated garden. So here's our x plus 7, like this length is x plus 7. This is sort of like saying, what's the area? Well, it's a times b. It's this times this. It's this times this, right? This whole thing is a, and this whole thing is b, right? So we're doing that sort of deal. So this length is 7 plus x, and this is 2x plus 8. I want to know the whole area. Well, there's 4 pieces. There's this piece, the x and this 2x area, right? That's this piece. So you have 2x squared when you multiply those. 2x squared. And I also have this piece that's x tall and 8 wide, so 8x, so I'm going to add that area in there, 8x. And then there's this piece that's 7 by 2x, right? So the area there is 14x. And we have this last chunk that's 8 by 7, right? It's 8 by 7, and that's just 56. Great. And so that's ugly, but we can still multiply it. And if you clean this up just a touch, turns into 2x squared, and 56. And you have 8x's and 14x's, and so you have what, 22x's? Great. All right, because we've added them up. Oh, I don't need that plus sign. Great. And so this is the expression for how big this garden is by multiplying two binomials. Cool? We can do that non-visually as well, and it's more efficient. So we're going to try the same thing. Notice that, like, when we were here, this piece multiplied by this, and we had two pieces there. We had these two pieces came from that. We said this x times this piece, and this x times that piece gave us these two pieces. And then also, these two, we should do it in purple. These two came from this 7 times 2x, 7 times 2x gave us this chunk, and the 7 times 8 gave us this chunk, right? So we said x times this and x times this, and then we also said 7 times this and 7 times that, right? We just multiplied each piece by all the other parts. So we can do that same thing here. We can say, without drawing a picture, we can say 7 times 2x gives us 2 times x times x, so 2x squared, plus x times 8, so that gives us 8x. And also, switch to purple again. You don't need to do this, but 7 times 2x gave us 14x, and 7 times 8 gave us 56. And then you clean it up. Yeah? So that's what's happening here, right? If you have a plus b times c plus d, you have to multiply each piece. So you have, here's your AC piece, here's your AD piece, here's your BC piece, and here's your BD piece. Should have done this part in blue. You get the picture. Great. So that's binomial multiplication, binomial expansion. Great. So this is the same thing. An easy way to remember that is called the FOIL method. And FOIL just stands for first, outer, inner, last. Yeah. This is a little convoluted. I might remove it. But really it says, okay, take the first ones in the line, right? So this is the first in its packet. This is the first in its packet. So here's the firsts, right? First. The outermost ones. So here's A and D are the outermost. So A and D. So firsts, here's A and C. That's the F. A and D, the outer. Inner, these two are the inside pieces. So B and C is there. And the last ones, like the ones that are last, second in their binomial, so B and C. FOIL, great. And so that's our piece, and then we'd clean them up if we could. So let's try the FOIL method here. If you know how to do it, pause me and give it a shot. If you're not super clear on it, we'll try it together. So I'm trying to multiply these binomials. I know that each piece needs to multiply by each other piece. So really, I'm going to multiply this by this, the first, and so this should be 2x times 3x, so 6x squared. First, the outermost ones, well, this and this are the outermost ones. So this is 2x times negative 2, so negative 4x. The inner bits, they're the innermost piece, so there is 1 and 3x. So that's plus, it's positive, so positive 3x. And then last is these two are last in their line. And so negative 2 times positive 1 is negative 2. And then clean it up, right? So 6x squared, and negative 4x plus 3x, so negative 1x, or just negative x if you like, and minus 2. Great, there she is. All right, take that idea and check this out. You can do this the long way. If you don't like the FOIL method, if you don't like that shortcut, you can do it the long way, or you can do it the short way. I'll show you this way. If you break this apart, I just wanted you to see that this also works. If you break x plus 3 apart into x plus 3, and you said x plus this plus x times this plus 3 times this, you end up with this piece, and you can boil this down from here and simplify this further, and then distribute this in here just like you've been used to doing. So x times x, there's our x squared. Keep going. There's our x squared, there's our 2x, there's our 3x, there's our 6, and it boils down to that, right? Simplifies to this. Great, fine. We can do this in a much shorter way by going, x squared outer 2x, inner 3x, last 6, and then you simplify it by just crunching those together. You get the same answer, just a little more efficient. Cool? So that's FOIL and binomial multiplication. So I'd like you to give it a shot on your own and try this. I hope I haven't foiled your plans. Get it? Plan. Because you foil the plan. Great. Solutions are up on the VLE. Give it a shot. You guys will do great. Sorry, I'm frozen. We'll talk to you later.